In this video, we are going to be talking about differentiation of implicit function. You see, if the relationship between variables like x and y are more involved, like they are very, very involved, it may be very, very impossible, or it may not be possible, or it may be difficult to separate y completely to the left hand side, which means it may be very, very difficult to make y the subject of the formula so that we can look for the y dx. You understand? So in a case like this, we call y an implicit function of x. You understand? Let us take for an example. We have something like 2xy plus cos y equals to 1. You see, in this case, you will see that x and y are so involved. They have been multiplied with each other to the extent that it is very, very difficult for us to isolate y into this particular side in making y the super formula. You see, in this case, we say that y is an implicit function of what? Is an implicit function of x. You understand? So in this case, what I'm just going to do, I'm going to teach you a very simple way and a very efficient way of calculating implicit function. We have two methods of calculating implicit function, but we are going to be using a very simple method of calculating implicit function. Now, let us take for an example. Let us say that we have a question like x squared plus y squared plus 3xy equals 5. So if you look at it very well, you will notice that this x and y, or this y, somehow they look somehow to me. You understand? It is just like we are now saying that in this case, y is an implicit function of x. So in this case, what I'm just going to do is that I'm going to apply something we refer to as partial derivative, partial differentiation. You understand? How I can solve it easily using, like, it's going to just be a partial, like I'm going to be partial with my differentiation. And that is basically given as dy over dx equals to minus x prime divided by y prime, or I can say that minus f prime of x divided by f prime of y, anyone that you want. It is just a shortcut of you getting how to solve implicit function easily. You understand how you can solve implicit function easily? That's just it. Now what I'm just going to do is that whenever I'm differentiating for the numerator, I'm going to be differentiating for only x. You understand? And I'll be counting anything that is y as 0, unless if x is multiplying y. You understand? And if I'm differentiating for the denominator, I'm going to be differentiating for only the denominator, and I'm going to be counting anything that is x as 0. You understand? Because I'm differentiating with respect to only y. You understand? So in this case, I'm going to be having something like, let me give a first example, because before I give that particular example, let us say our dy, let us say our y equals to x squared plus y squared minus 2x plus minus 6y plus 5, everything equals to 0. You understand? So it's not y equals to, sorry, this is the equation: x squared plus y squared minus 2x minus 6y plus 5 equals to 0. Remember the formula that I gave you? I said our dy upon dx will now be equals to f prime of x, which means differentiation with respect to x, and f minus f prime of x and f prime of y. So I said that whenever I'm differentiating for the numerator, I'm going to count everything that is y as 0. And whenever I'm differentiating for the denominator, I'm going to count everything that is x as 0. Which means in this case, if I differentiate this one, since it is x, I'm going to put minus first, then open the bracket. Since this one is x, it's going to be equals to 2x. You understand? This one is y squared. Remember I told you for numerator, anything that is y is going to be equals to 0, so plus 0. You understand? And this one, since it is x, is going to be minus 2, because if I differentiate 2x. Since this one is y, is going to be what? Minus 0 because it has y. And 5, differentiation of constant number is always equals to 0, right? Divided by, then let me differentiate for the denominator. I'm differentiating with respect to y now. So since this one is x, is going to be equals to 0. Plus, since this one is y, I'm differentiating with respect to it, that is 2y. Since this one is x, that's equals to 0. And since this one is y, that's equals to minus 6. And the constant number is going to give us 0. And this is our answer. You have gotten your answer like that. 0, everything goes. That is minus into bracket 2x minus 2, everything divided by 2y minus 6. That is our answer. Just one step solving, you understand? So it's not difficult. Implicit function, it is not difficult at all. Understand? Implicit function is not difficult at all. So let us take for an example. We now want to use this particular one as an example. Let us say we have x squared plus y squared plus 3xy equals to 5. I can bring this 5 to the back and I'll be having minus 5 equals to 0. So the same thing, the y upon the x equals to minus f prime of x minus f prime of x divided by f prime of y. You understand? So what is going to happen in this case? It is not difficult again like that. We're just going to say that minus first, then open the brackets. You understand? If you differentiate this one, since it's with respect to x, I'm going to be having 2x. This one is going to be equals to plus 0. But you see this one, I cannot count y as 0. Why? Because y is already multiplying x. So the only thing I can do is that I can differentiate with respect to x only. So I can differentiate with respect to x and I will leave y alone. So if I differentiate 3x, what am I going to have? Our answer is going to be equals to 3. Since y is there, I'm just going to say that what? Plus 3y minus 0 because 5 equals to 0. So do you understand what I did now? So what I just did is that 3xy, it will be equals to like 3x raised power 1y. So I'm differentiating only with respect to this. And that will be equals to what? 3x 1 minus 1y. That is 3x raised power 0 y. X raised power 0 equals to 1. So that is equals to 3y. So that is exactly what I did here. So I'm going to do the same thing for the denominator as well so that you understand very well. So divided by, this one will give us 0 plus, this one will give us 2y. And for this one, since it is 3xy and I'm differentiating with respect to y, that will be equals to 3x y raised power 0, and that will be giving us what? Just 3x. That is plus 3x minus 0, which means our answer for this particular case is now going to be equals to minus into bracket 2x plus 3y divided by 2y plus 3x. And this is our answer for this particular question. So let us take another example. Let us say we have something like um x squared plus xy squared, or let me see, x squared y cubed minus 2x minus cos y equals to 0. So that one is not hard. What am I going to do? I'm just going to say that the y over the x equals to minus first, then differentiate with respect to x. I'm going to be having 2x plus, if I differentiate this one with respect to x, I'm going to be having, it is only this x that I'm going to differentiate. It's going to be giving me 2x y cubed. You understand? I'm going to leave this one alone. I don't want to differentiate it at all because it is multiplication, and if I turn it to 0, everything is going to become 0. Minus, if I differentiate this one, it's going to be 2. And this one, since it has y, it is equals to 0. So I'm closing my bracket. This one is going to be equals to 0 plus this one like this is now going to be equals to what? I'm only differentiating with respect to this. So it's going to be 3, or let me say that x squared multiplied by 3y squared. You understand? Because I'm differentiating only with respect to this. Minus this one becomes 0. And this one becomes what? Becomes minus sine y. Because cos equals to minus sine. So that's equals to minus into brackets 2x plus 2xy cubed minus 2, everything divided by x squared, everything divided by 3 multiplied by x squared will give us 3x squared y squared plus sine y. So this is how to solve implicit function. You understand? So this is a very simple method of solving implicit function. In the next video, we are going to be talking about how to determine the maximum and the minimum and the maximum, and also how to construct the turning points of a function. You understand? How to determine the turning point of a function. So to the next class, thank you and subscribe for more.